In this problem, we're going to go back to forces a little bit to talk about Hooke's law. So, Hooke's law is that a force of a spring is equal to the negative of the spring constant times the change in the displacement. So, we have a box being pulled by a train with a pulling force F pull. It has a normal force because it's on the ground. It has a gravitational force because it's on the earth. Let's make that look a little nicer. And then it has a force of friction, F static. So the sum of all the forces in the y direction is the normal force minus mg, and that is equal to 0 because it is not leaving the track or going into the track. So that means the normal force is equal to m times g. Oops. So the static friction force is mu s times Fn, and we know Fn is now equal to mg, mu s mg. So the sum of all the forces in the x direction is equal to max, which is equal to 0. And that is equal to the force of the pull of the spring minus Fs. That equals 0. So that means the force of the pull is equal to Fs, so mu s mg. F pull is equal to k delta s, and that equals mu s mg. So note, I didn't include the negative sign because the negative sign just indicates direction, and we defined this way to be positive x. So to solve for delta s, we just divide both sides by k and get mu s mg over k. So then we plug in our answer, or our numbers, 0.6 for mu s, m is 2 kilograms, g is 9.8 meters per second squared, and our spring constant is 50 newtons per meter. That gives us delta s of 0.235 meters. So that's how far the spring compresses or is pulled apart. The time is delta x over v, and that is 23.5, 0.235 over 0.05. So I converted my velocity to meters per second, and this is meters, so we get 4.7 seconds.